Okay, so from table 12.2, we see that the intensity of normal conversation at about 50 centimeter distance is about 3 times 10 to the power minus 6 watt per meter squared. Now we know that the intensity is the power output per unit area. That's going to be our power output per unit area. So the power output is um, and we can figure out the power output, and for area, as it's a sphere, so we have to find out the surface area. So we can write that intensity is equal to power over unit area. Now we can write this as power, which is equal to intensity times area. And for our case, we know that intensity is 3 times 10 to the power minus 6, and area is the area of the sphere. So we'll have I times 4 pi r squared, which is the area. Now, if we plug in all the numbers, we'll have 3 times 10 to the power minus 6 watt per meter squared times 4 pi, and um, r is 50 centimeters, so we can convert that to meters, and that's going to be 0.5 oops, 0.5 meter squared. So 0.5, there's going to be a square, and then we'll have meter squared, right? And if we solve for it, we'll get something like four, no, we'll get something like 9.425 times 10 to the power minus 6 watt, or if we approximate it, it's going to be 9.4 times 10 to the power minus 6 watt. Now this amount of power output is when you have only one person speaking, right? And if you want to get the number of persons, so now we have 60 watt of total output, and 60 watt of total output, and we know that for each person it takes 9.4, or let's actually take the actual number, 9.425 times 10 to the power minus 6 watt output for 1%. So that means to get 60 watt, we need to use this equation where one person is generating 9.425 times 10 to the power minus 6 watt, and that'll give us the number of person we need. So that's gonna be 6.37 times 10 to the power 10 to the power 6 people, or if we again approximate it, it's gonna be 6 million people. Thank you.